Here's number 42 in section 4.4, and you can read this over on page 229. And it says, how close is a semicircle? Y equals the square root of 16 minus x squared. Come to the point 1 square root of 3. So again, we want to find a point on the curve, or the point on the curve that is the closest to this point. So we want to find the distance between these 2 points and take the minimum of that, just kind of like we did in 41. Well, this is going to be a little trickier, so. You have to do this with the calculator. But let's take a look at this. Let's substitute it in. So distance equals, I wrote my distance formula already, so we'll just substitute in. Like we did in 41. So this is going to be x, and that's x2, and x1 is 1. And then we have y2, which is y, and the square root of 3. Okay, and again, we need to have this in terms of x. We can't do it like it is, so right here we've got kind of like a constraint that y equals the square root of 16 minus x squared, so I'll put this in here. Okay, plus, and this is going to be the square root of 16 minus x squared. Right, that's y, minus the square root of 3, all squared. And as Dale Dribble would say, not a pretty picture. Okay, so we got to square all this out, and these aren't going to combine or simplify like some of the nice ones I've been giving you on your quizzes. So we're going to have to work a little bit at this one. So distance equals, give myself lots of room here, x squared minus 2x plus 1. So that was nice. And then we got to square this. So it's the same thing, the first term squared, so that's going to be 16 minus x squared. And then minus twice the product. And then plus this squared, which is 3. So I have to simplify this as much as we can, and what I notice is that x squared minus x squared, those go away, so that's a relief. And if I add up my numbers, I've got 16, 17, 18, 19, 20, so that's a 20. And minus 2x, and then I've got minus 2, and I can put this 3 under the radical, and I can multiply this out. So that's going to be the same thing as the square root, I'll just do it as a step so you can see that, of 3 times, because they're both under the radical, 16 minus x squared. And then we can multiply that out to make it a little bit easier, so distance equals 20. There we go, down here. Minus 2x minus 2 times the square root of 48 minus 3x squared. Now again, we want to minimize this, so we're going to use this function g of x, which is going to be under the radical. So we're going to say distance equals g of x. All right, so I'll take this g of x out, and I'm going to write g of x, or write this as g of x equals 20 minus 2x minus 2 times the square root of 48 minus 3x squared. All right, so that's what we want to minimize. If we minimize that, we'll minimize the distance, but then we're going to have to kind of put this back in under the radical. We're going to have to take the distance will be the square root of this function. But I got to take the derivative, and that's going to be kind of like a hassle, so a lot of work. I don't want to do all that right now. So remember, I showed you some nifty ways to do this on the calculator. So let's see if this can be worked. This can be worked out on the calculator. So we'll show you, and this was something I showed you on one of the problems. I think a couple of days ago. So make sure you can see all this. And I have to hurry up because when I do the calculator, it takes more memory because it puts all this stuff in here. Okay. So what I'm going to do is I'll put this thing on. Let me clear all this. This is some old stuff. And then I'm going to put this function in, so it's going to be 20. So I'm going to actually put my function and then I'm going to take the derivative and actually graph it. And I showed you how to do this before. It's kind of nifty. It saves you a lot of work. But you can't see it on the paper, so you pretty much have to do it on the calculator, right? So we're going to put 20 minus 2x minus 2 radical, and then I've got 48 minus 3x, and that's going to be squared, and that's all under the radical. So take a look at that. Okay, so that's g of x. Now we want to take g prime of x. So g prime of x is what we're looking for to find the minimum. Now this won't tell me what it is, but remember I can go down here to the second one, and I can put math 8, because that's going to take the derivative, and I go var, y vars, enter, and that's going to put y1 in there, so I'll select enter, and that's y1, which is up there. So right here I'm going to take the derivative of this function, and I'm going to graph it, so I put comma x, because it's with respect to x, and it's just the variable, so that's going to give me the graph. And that's how I'm going to find my relative extrema. So I'm going to go back up here. I'm going to turn the function off because I don't want to graph that. I want to graph the derivative. And then we can go to zoom, and I'll try zoom 4. And here it comes. It's a little bit slower because it's doing a lot of work. It's taking a big derivative there. And then I'll try to find this 0 over here. So I'll go second, calculate, down to 0, enter, and there's my left bound. It's going to be easier to see my left bound, at least on this one. And there's a good left bound, enter, and then I'll go right bound over there. And notice how my derivative is going from negative to positive, so that's going to be a minimum. Remember, it's going from negative to positive. So here the slope is negative, and here it's positive, so you see our function is going to actually have a minimum value there. So then I'll press enter again there. Don't want to guess. And it looks like I've got 1.9999999. That's pretty much about 2. So that's going to be my relative minimum. Okay? At x equals 2. So I don't have any values here, but I know the relative minimum. It's going to be at x equals 2. I didn't have to do this because I got the graph right there. The only reason why I find that is so I can graph it and find that. Okay? So now we want to find g of x, and then the distance will be the square root of g of x. So how do I find g of x? Well, remember, this is the nice thing about doing this with all these little functions here on our calculator. I go back over here, and if I look over here, y1 is g of x. So if I want to evaluate that, if I want to find g of 2, it's going to give me my distance. All right? So my distance will actually be g of 2 because x is the value that's going to work. So I'll just go over here, back over to the home screen, and I'll go var, y vars, enter, enter, And if I put a parentheses, parentheses, and if I put 2 there, that's going to evaluate y1, which is the g of g, and that's going to be g of 2, and that's going to be 4. So g of 2 is 4. All right? So I'll put this over here. So I know g of 2 is 4, so my distance equals the square root of g of 2, which is equal to the square root of 4, which is just 2. So there you go. Hope that makes sense.